Jeffrey, are you speaking?
I'm not speaking. Do you want to run
Cannot
it?
hear you.
I
You're
can
on
hear
mute.
you. I can hear you. Can anyone else hear me? I'm not on mute.
Hey, yeah, I can hear you too.
Yep,
Okay, great.
me too.
Okay. People are still trickling in.
Can you hear me?
Yeah, I hear you, Jeff.
Okay. Well, people are still trickling in. Let's give it 1 more minute. So Jeff, do you want to run meeting?
Can you hear me?
Yes, I can. Can you
Oh,
hear
good.
me?
Yeah.
Okay.
Yeah, I can hear you.
Okay. Do you want to get started?
Yeah, it's about time. Good morning to everybody. Hey, Jeffrey. It's an early morning in California. So, welcome to IETF 112, again virtual, and please note well, by participating in IETF, you agree to follow IETF process and policies. Specifically, we would also like you to ask to be polite and treat your fellow IETFers with respect. There have been a number of events where it wasn't so, luckily not in our working group, but we would like to emphasize the point that it's a no harassment environment. We would like you to act accordingly. Working group status. If the base spec has been waiting for AD review, Alvaro is here. We had a meeting a couple of days ago, and Alvaro promised to do it by the end of the year, which is pretty close. Applicability statement almost ready. We got good reviews. We finally also got all the IPR statements here. In agreement with Alvaro, this will be handled together with the base spec. So when it goes through IFG review, they could actually cross-reference both documents. Young draft had addressed, Jeffrey, you were saying? Okay, Young model has addressed comments received from young doctors, and from chair's perspective is ready for working group last call, which we will start soon. KV registry, we would like to ask the authors what they think with regards to upcoming changes, if anything needs to be changed, and when do they think to be ready for working group last call. Our TVPN draft is in progress. There's really good progress. I think there's also common implementation. Multicast and segment routing. We decided to kind of keep them on site. We are still working on. We are going to refresh them, but we are really waiting for deployments and to better understand the requirements for SR. And we would also like to recharter mid next year after both applicability statement as well as base spec have passed IOG review. Any questions, comments, working group? Alvaro? Okay, then.
I will just make a quick comment on the KV registry. We're probably just going to wait for the base spec before we go working group last call, but no major changes needed at this time.
Okay, makes sense. Thank you.
Yep.
Okay, this is to finalize working group status. And last slide. We can go into presentation.
Okay, I'll take over from here if that's cool. So thanks, chairs, everyone. I just kind of want to take a few minutes to share updates on Auto EVPN. Next slide, please. So main changes from last time. First and foremost, working group adopted. Thank you, everyone, for that. Beyond that, we've started working in some foundational components for data center interconnect variable derivation. With that came a few considerations to how we elect the top of fabric route reflectors. We also worked in some multi-plane fabric components there as well. We increased collision-free scale. Tony was able to squeeze some more out of the hashing algorithms. And we've also added a operational section. Some of the feedback, indicated that it would be helpful and get into a little bit more detail. And then just minor restructuring, nothing terribly exciting there. Next slide, please. So DCI gateways aren't anything new in the general sense, but we've started working them into Auto EVPN. Most of the work so far has been done on the top of fabric route reflectors. Basically, we also allow them to perform DCI gateway functionality. So with that, we had to factor that into the route reflector election. First, we are advertising a new bit in the node tie to kind of convey if a top of fabric node wants to perform DCI functions. And then second, we alter the election schema a little bit, which we'll get into here. Next slide. So looking at single planes, the previous election procedures were pretty straightforward, highest SID, lowest SID, second highest, lowest highest, or lowest and so forth. Now we just work in that DCI bit as to prefer them. So now we would say, highest SID with the DCI bit, lowest with the DCI bit, second highest. And then if at that point, depending upon your deployment, like if we were to have a top node that wasn't doing DCI gateway stuff, we could just kind of fall back to the typical election procedures there. So basically we just, to reemphasize, we prefer the DCI component to it. Next slide. And so for multi-plane, we basically take, among all of the top nodes in a plane, we declare a plane ID, and that is the highest SID from each of those planes. Everything's carried in the node tie already. So the election is distributed across planes as, highest plane ID with DCI bit, lowest, second highest, and same as before, if we have any that aren't doing DCI, we just fall back to it that way. So this basically will distribute route reflectors and the DCI gateways across planes for some redundancy there. Next slide. This one's pretty straightforward. Previous scale was, 3 fabrics, each with 3 EVIs, and each of those with 15 VLANs apiece. Now we can do 6 fabrics, 7 EVIs, and 30 VLANs. And same as before, we can go higher, but we have to define those, how those are derived, so they remain collision free. Next slide. And last but not least, we added an operational section. there was some, basically feedback saying this would be helpful, and that not only for single plane versus multi-plane sort of things, but also for those who are not incredibly familiar with Rift or Auto EVPN, to kind of help them bridge that gap a little more quickly. So there's some example topologies in there that sort of take existing terminology, from like the physical underlay as a super spine, how that translates to Rift is, top of fabric, and then Auto EVPN as a route reflector or DCI gateway. And there's a, full topology there kind of showing everything. Little bit of restructuring. Basically, we folded the analytics section into the operational section. And then finally, a little bit of a quote unquote pix pro forma for this scale mentioned on the previous slide. Basically, there is a table at the end of the document in the appendix that you can basically use to confirm compliance with the current version of Auto EVPN. And next slide. So as always, co-authorship comments are welcome. But for next go around, it'll, more DCI examples, more multi-plane stuff, more operational considerations. That's it from my end. If there are questions, next slide. And if not, maybe I can steal a couple of extra minutes to go through something that you guys might find interesting too.
Please do.
Okay. First off, any questions about the? I jumped to the next slide, and I guess first, are there any questions or comments about Auto EVPN itself?
Tony here, Tony Juniper. A quick observation. So, as input from people playing with it, there was a desire that the hash function actually is delivering some kind of a continuous, simple VLANs for the Fabric ID1 and EDI1, which is kind of the default case. So I'll be probably still fiddling with the hash function to get, in Fabric ID1, EDI1 default case, something like, VLAN 1, 2, 3, 4, 5, instead of what we have now, where, we have 1, 2 VLANs which are in low range and they start to jump up. Probably for the next release.
Should I go to the next slide?
Yeah, let's jump forward 2 slides. So I'm going to kind of shift gears for a second, just breeze through something. So just kind of a quick teaser, something we're working on that's, not directly related to Auto EVPN, but, if you're interested in kind of the true ZTP sort of, underlay fabric sort of provision, this might be pretty interesting for you. Just next slide for me. I'm going to kind of breeze over these pretty quickly, just to provide some high-level context as to what we were working on. So I think zooming out a bit, we all kind of know that flat single area IGPs come with pitfalls. Lots of flooding, lots of state, lots of convergence, and this just gets worse as the network scaled. But there are desirable reasons to deploy these sorts of things, like SR makes things simple. Next slide. So one way we address that problem is with flood reflection. So it's based on some existing LSR work. There's a new version posted for, don't know offhand when the meeting is, but there'll be a new one presented this time. But they, at a high level, work a little bit like BGP route reflectors in that we designate a flood reflector and we have, one or more clients. But the end result is we can squeeze a lot more scale out of those sorts of networks. So a lot less state, less flooding, less SPF computation. Next slide. So just for the visually inclined, just if we had a really basic example kind of comparing the two, if we needed, full mesh of level 2 adjacencies between, tier 1 and tier 3, right? That's the only real reachability information we needed. Flat single area, we need, 15 adjacencies. But if you look on the right, we have, you'd only need 8. So basically we have tier 1s establish those flood reflector adjacencies with those nodes at the top are the flood reflectors and those nodes at the bottom are the are the clients. Again, pretty simple to, I think, kind of extrapolate and scale impacts there as you continue to grow the network. And next slide, last one. So basically, what's this got to do with auto EVPN? Well, we're taking the same kind of technology, the automatic variable derivation, and applying it to that. So we figure out the cluster ID, which is, how we keep things unique within the fabric, and then, the role, whether it's a client or a reflector. So it's, not an incredibly complex addition to it, but super beneficial. So stay tuned for that. Check out the drafts. It's pretty interesting work. But that's all I had. I don't know if Tony has any comments.
Oh, I typed something quickly to the chat, which, why the flood reflection is different from normal areas. Otherwise, yeah, we'll probably have a draft out next IETF with the whole thing, yeah. And that will give us a day zero flood reflection technology, basically.
So these slides are basically a teaser for some upcoming work?
Yeah. So the draft will be for 113.
Okay. Thank you.
So for better understanding, Jordan, you're presenting as part of Auto EVPN. Would it also apply to base Rift in any way?
Oh, sorry, muted. No, this is a little bit separate.
Okay, thank you.
Just sort of the the auto EVPN, the sort of automatic derivation sort of thing, more than anything.
So it basically the same thing as Auto EVPN. It extends the schema in a minor way, so it's backwards compatible, but there are some new elements of the schema, mostly just to make sure that you don't misconfigure it, that everybody, in a cluster, just like Auto EVPN, is kind of, in the same fabric, right? So it touches the base spec, it extends the base spec in a backwards compatible way. So the stuff will run with basic Rift as well, but the extension will allow you to run this Auto EVPN auto flood reflection. But those things are completely orthogonal to each other. So the Auto EVPN and auto flood reflection are independent. You can run both. You can run either. And if you think about flood reflection, depending how you build it, you can actually see Rift just a day zero protocol, because auto flood reflection will be able to even configure ISIS L1 and L2, or you can just configure L2 and use Rift underneath as a forwarding protocol. Will provide both options.
It sounds pretty exciting to me. Cool.
So that is the only agenda item on the table today. Unless we have any other comments, discussions, then
We can give you some time back.
Yeah.
Okay, cool. Thanks, everyone. Bye-bye.
Thanks, everyone, and see you
Thanks, folks.
wherever we are going to be at 113. Thanks.
Thanks. Yeah. Bye.
Bye.